Hello students, this video session is for class 10 students. The subject is general science and the chapter is light reflection and diffraction. You will find this chapter in your main book in chapter number 10. Let me tell you that this video session is not an explanation on this chapter because the explanation has already been done in your classroom. Neither I am going to discuss with you how the mirrors look like, nor I'll be discussing with you how the image formation are drawn for different types of mirror, because these things are already been discussed in the classroom. However, if necessity arises, I'll be making some separate video for that. But today in this session we will be talking about a numerical, the numerical which came in the HSLC examination 2020, which was there for 5 marks. If there is any student who has collected the question paper, you will see that the question is question number 30. The question is this one. You can pause the video and read the question by yourself, but I'm doing it once for you. The question is, an object of size 70 mm is placed at 27 cm in front of a concave mirror of focal length 18 cm. At what distance from the mirror should a screen be placed so that a sharp focused image can be obtained? Find the size and nature of the image. So what we have to do here is, the very first thing we have to do is we have to understand the question. Second thing, you have to visualize the diagram, and the third thing, you have to understand what quantities are being asked to find. Okay, the prerequisite, the basic things that you must understand, you have to know before solving this question is here. The first thing, how mirror looks like. The second one is the sign convention and the orientation. What is orientation of the mirror? I'm coming. Third number is the image diagram, which I have already said. Right after reading the question, you must be able to make the diagram in your mind. And the fourth one is the formula. Now, formula is a secondary thing, because if someone has the clarity of concept without knowing the formula also, he or she can solve the question. But at this level of class 10, formulas are important. You have to memorize the formula. But if you move on to higher classes, you will know that without the formula also you can deal with various numericals, various problems to be precise. Okay, so the question was based on concave mirror. This is the concave mirror I have drawn. There are two ways by which we can draw the concave mirror. One is this, the another one is this. Again, I have told to everyone that while we draw like this, there will be a minor change in the answer, in the solution. Minor change as in you will get the same numerical value, but the only difference will be based on the sign, whether it's positive or negative. That's the only difference you will get. But again, logically these two are correct, both of these are correct. It's up to you, it's up to the student's wish, whichever way he or she likes to use. But for our simplicity, and as far as I remember in the classroom, we have, based on your choice only, we have used this one, the left hand side one. So this positive and negative is based on sign convention. Sign convention we have already discussed. However, a simpler version is being drawn here. A simpler version of sign convention has been drawn here. You can see on the right hand side is positive, on the left hand side is negative. Above the principal axis is positive, below the principal axis is negative. At the top, positive, below, negative, left hand side, negative. You can see all this. We have already discussed this. And the formula also, this is the formula that we have to use. There are three formulas. Actually, there are two formulas. These two formulas are of the same version. I mean, you have to use either of it. It's not like you have to use both of them. However, this is the one. This is the one for which, I mean, this is the one we need to find the distance, and this is the one. These two are the one we have to use to find the nature. Okay. Now for nature, I have already written here. For the nature we have two formula. Now which one we have to use is totally based on your logic. After understanding the question, the quantities which are given in the question, after understanding and after knowing those things, you will be able to know it by yourself that which formula is applicable for finding the nature. In this case, let me tell you that we have to use this one first. We'll be doing that, you'll know how and why. We have to use this one first, and after this is used, we'll get something, some value, and that value we have to use in here of finding the final answer. Because you can see, if you move on to this question, you can see that we have to find the size and nature of the image. We have to find the size of the image. Size of the image means we have to find h dash, okay, and we have to find the nature. Nature means, again, based on this sign we can deduce what kind of nature it will be having, either it's real or virtual. Again, what is real image, what is virtual image, all these are already discussed, but again, if you want me, then I'll be making some separate video on all those topics. Okay, let me come to the discussion again. So based on this question, based on this question, if we draw the diagram, you'll see that this is somewhat the diagram is. And also, I did not tell you one thing, let me tell you that here you can see that the object distance is 27 centimeter, the focal length is 18 centimeter, and double of focal length is the radius of curvature, so it would be 36 centimeter, is not it? And the object is at a distance of 27 centimeter. So what do you understand? You understand that the object is between the center of curvature and the focus, and when the object is between center of curvature and the focus, the image is formed beyond the center of curvature. That means the answer that we will be getting should be more than what? More than 36 centimeter, is not it? Because the radius of curvature is 36 centimeter, it's double of the focal length.